Hey guys, today we are going to go through maybe one or two problems. So I'm going to do Pascal's triangle, two, and then I might attempt Ron Orange's an Excel sheet column number. It just depends on how tired I feel. But yeah, let's maybe H index. Let's see. Just depends on the question. All right, give me shins research right function. The computer science is H index according to a scientist has a index H if his or hers have at least H citations, and others have no more than C citations. So citations, I'll put 3. So according to index H divided by N papers, if each of his papers at least H citations are okay, so there's okay. Okay. Okay, given the array. Okay, so this one seems like a binary search problem I could do. So you have 5 papers. Each of them have, since the research has 3 papers with at least 3 citations, 3, 6, and 5. The remaining 2 with no more than 3 citations. Her index is 3. Okay. Mm-hmm. Scientist has index H if H of his or her N papers have at least H citations each, and the other have no more than H citations each. Okay. Okay, I might solve this one too. This one seems interesting. Okay, oh yeah, and I'm going to be solving this in Java, so let's try this out. So yeah, if you just sort the citation arrays dot sort citations, let's print those bad boys out and return no. Citations. Okay, let's see if this is sorted now. Okay, oh, just do 0. Okay. So is this sorted? Oh, good to know. Okay. String dot value of, because I just want to see if it's been sorted. The reason I'm doing this is because with Python, there's different types of return types for your arrays. So you have one without side effects and one with side effects. So the side effects one obviously returns the array sorted in place. And let's see. And there's one where you create a separate new array. Okay. System out print array Java. Let's figure out what I'm doing around here. Oh, okay, arrays toString. Good to know. Arrays toString. Okay, so the thing I immediately thought about is this problem is a binary search problem, or it can, and maybe not binary search, but you can easily solve this, or more easily solve this by sorting. So by sorting, you have more clarity, and then you basically just iterate, or you could almost do like binary search to see if you meet the H index condition. So let's see. Okay, so now this is sorted. Good to know. All right, so you basically just check to see if a majority, let's make sure, scientist has, and let's look at the H index too. Given an array of citations, each citation is non-negative integer. Write a function to compute the H index. A scientist has an index H if his or her N papers have at least H citations each. And the other N minus H citations have no more than H citations. Okay. So 5 minus 3 is no more than, okay, so if it is less than or equal to 2, perfect. Okay. So then you would iterate backwards, I believe. And then you just find the first instance where that value breaks that H index. Okay, so we know that H index is N minus H, right? H index is N minus H. So let's get the N length. Length equals citations dot length. Okay, so, and then our H value will be whatever value we're checking, and we're making sure that's a majority, right? So if the value is 3, at least 3 of the citations have to be okay, so there's actually 2 conditions. At least H citations each. Each. And the other N minus H papers have no more. Respectively, since we have 3 papers with at least 3 citations each, 2 or no more than their H index is 3. Okay, good to know. Okay. Okay, so maybe we can start in the middle, and then depending on the H value, it checks to see if, okay, I think this makes sense. So yeah, we have like left and right, and okay, then the value, so left equals 0, and right equals lang minus 1, and mid equals left plus right minus left by 2. Oh, divided. Okay, divided by while left is right. So yeah, now I'm just doing a binary search. When I'm gonna just check by mid. So instead of having to search through everything, I kind of just know because it's ordered where to structure things. So with this, now I check to see if mid So then you would have to make sure that everything to the left doesn't get repeated from what I'm seeing. At least. So I guess I'm getting a little confused right now because if you store everything, then okay. Means that the researcher has 5 papers in total. Each one of them has, since reporter has 3 papers with at least. So this case, would you go to mid? So that would be 3, 5, 6. So length minus mid. Okay. So then you just go for diff, int diff equals right minus mid plus 1 plus 1. Okay. Maybe I'm not understanding this problem correctly. Given an array of citations, each citation is a non-negative integer for a researcher function to compute the researcher's H index. Okay, let's look at the H index to measure both productivity and citation impact of. Okay, get that on the field. I think this is like, yeah, binary search. Okay. At least if H of his have at least eight citations each. So if you have an array 4, you at least have 4 papers with more than 4 citations. Okay. So this is just an order. So you have at least 1 paper. Okay. Okay, I think it's making more sense now. So like, let's say you have a super long array and everything's in order. So let's say in the middle of your array you have the number 400, right? So each one of those elements, like 400 to the right, that has a number greater than 400. So there's at least 400 papers. 400 papers that have 400 citations each. Okay. Then when you go into the left, you're reducing that number. So 400's your main thing. If that's not the case, then check again. So if you had like a bunch of zeros, then you would want to move to the right. Okay. If that's not the case, then you would want to move to the left. What would be a case if you want to move to the left? You want to increase the overall number. Okay. So then you want a min value of the value or the number of actual papers. What happens in the case you have an array of 3 elements with a value of 4, then H index would be 0 because there are not 4 papers with 4 more citations. Oh wow, this is a super interesting problem. I don't know this one. Yeah, okay, so the array with the possible values of an H index. So it goes all the way from 0 to infinity. So they want me to use extra space. Okay. Maybe you could do a hash map of all the values and just iterate over that. So that's an interesting one. Maybe I could do Pascal's triangle. Okay, so for Pascal's triangle, let's look at the algorithm. So remember this, n minus 1, k minus 1 plus n minus 1. Is that divided by k? I guess it is divided by k. So this is almost like a... It's almost like the entry in the nth row and the kth column is noted as this. So 0 to 7. So it starts at 0, so it starts at 1. So you basically have half a 2D matrix. So you could use some recursion here. So 7 minus 1 divided by, and what was k denoted as again? Column. Okay. So then you would do it iteratively. So from 0 to 1. So then you just do 1 minus 1, 1 minus 1, 0, 0 divided by k. So this is a combination essentially. Okay, that's what I was looking for. So yeah, you have half a triangle you can do. So 1, and then you're on the next row, so you're at 1, 1 minus 1. So this is the row, this is the column. So k equals 0 in this case. K equals 1 in this case. So 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Okay. So when this starts at 1, which is good to know. Okay. So let's look at that formula, and then we can start a 2D matrix, I believe. Okay. N minus 1 divided by k minus 1 plus n minus 1 divided by k. Okay. So let's do that. Let's call this triangle equals new and oops, row index. And then I think we just do this iteratively. So for int I, or we could just call this k equals 0. Maybe we just call this n. I mean, they both can be 0. Okay. And so basically I'm just following the formula we see here, and then I just build from this. And one thing I forgot to do is for triangle 0, 0, it's going to start at 1. So it's easy to build on that. So for example, n minus 1 would be, we start at 1, okay. That would be 0, 0. Okay, I think I got this. This is the row. 1, 2, 3. Okay. Okay. So n by row index, n plus plus. Okay, let's make sure I get this right. Nk. So we both start at 1. 1, 2. This makes more sense. Okay, 0, 0. So 1, 2. 1, 2. 1, 2, 3. 1, 2, 3. So then I would need to go from 0 to n. Okay. From k equals 0 to k less than n, k plus plus, then this is where we get our triangle, n, k equals, and then we have the formula, so n minus 1 divided by k minus 1 plus n minus 1 divided by k. You can't divide by 0, so then you would just do it like that. Okay. Then, okay, so let's do system.out, make sure I'm not representing what I think I'm coding. Arrays.toString on triangle. Okay. We're missing return statement. Oh, okay. Sorry about that. Return new array list of integer. All right, so we run this. I just want to see like if what I'm trying to do is happening. Oh God, okay. Right, index. So -1. Okay. So 0, 1, 0. So maybe I got this one wrong. Zero is going to cause some issues. Yep. Division by 0. Okay. Let's see what's happening here. So 0, 1, 0, 1, 0, 0. Okay, Pascal's triangle. So yeah, this is a combinations problem. Okay, Pascal's triangle. Formula. Oh wow, okay. Counting numbers. So what's the formula? 3 plus 6. So 3 factorial. Okay. Oh, is that the issue? Okay. Okay. Let's go back to a wiki and see if we have this issue. Okay, I think this is more what we're looking for. So n factorial, so this is actually n factorial divided by k factorial, n minus k factorial. Okay, so I like this better. So maybe we'll have like a factorial here, maybe like a class. Okay. Okay, public. So basically right now I'm just creating a factorial which should return a number. So int factorial mem. So we're going to memorize that. So factor, it's factor, and then also map of integer. So 4 equals 24, yeah. So integer, memo equals, so Java default parameters. I don't think it does, so I don't think it can do that. No. Yeah, overloading. Okay. So yeah, this is a little bit different than Python. Okay. Okay, so we're just going to do a really inefficient factorial. So if factor equals 1, return 1, return factor times factorial factor minus 1. Okay, so let's redo that. Okay, factorial n divided by factorial k times n minus k factorial factorial. It's going to be really slow, so I do not envision this passing it. If I get there. So row index 2. Yeah. Yikes. Okay. Yeah, so I need to get better at that. So I actually don't even need to do this factorial, because I can just build from there. Okay. Sorry, guys. I'm going to have to go back to the drawing board and see what I did wrong. These combinations and permutations of questions get me a lot, so I'm going to have to do some research. But yeah, I'm going to try to do better on these next Friday's video. But yeah, thank you for watching, and the journey continues. Cheers.